Here's problem number 35. We're asked to find out if this converges or diverges. It's not a geometric series, so that's not going to do any good. Between n squared and what is effectively 1 over e to the n is going to win, and so this limit as n goes to infinity is going to be 0. So nth term test for divergence isn't going to help us. Let's go to the ratio test and see if the ratio test can help us out. So in the ratio test, take the limit as n approaches infinity of the absolute value of the n plus 1 term, n plus 1 squared times e to the negative n plus 1 all over n squared e to the negative n. Let's see what we get. Limit as n approaches infinity, n plus 1 squared over n squared. Well, this thing is clearly going to end up being 1. The largest term here is going to be n squared. Once I distribute that, or do the FOIL method, I got an n squared on the bottom. It's going to go to 1. But what about this mess? Let me rewrite that. It's e to the negative n minus 1 over e to the negative n. Well, one way to deal with that would be, I still haven't dealt with the limit yet, so I'm going to have to continue writing n plus 1 squared over n squared. Hopefully you're doing it in a cleaner fashion than I am. How about e to the n minus 1 minus a minus n? I'll take the two exponents, I'll subtract the numerator one by the denominator one, and when I do that, what do I get? Well, I get negative n minus 1 plus n. So these n's cancel out, which means when I finally apply the limit, I'm going to get a 1 from here, and I'm going to get an e to the negative 1 there. E to the negative 1, by the way, is less than 1, and therefore this series, n squared e to the negative n, converges by the ratio test.